I've been saying such amazing things. I just told you all the solutions to all of the homework problems this semester. The key to a happy, fulfilling life, and I've been muted. All right. Well, that's one way to kill some time. Anyway, so let's back up a little bit. Today's lesson, we're looking at the enhanced for loop and how we can write code that actually participates in that loop. In the sense that this is another place in Java where we have an interface. And this is cool because it's actually kind of built right into the language. There's an existing language feature. That's not always the case. This is sort of a cool example in Java of an existing language feature that we can tap into by implementing an interface. So if I go back over here, what we see is that we've used this enhanced for loop before really to go through arrays. But what's on the right side of that colon, all it has to do is be able to participate in this contract, right? Interface is a contract. Interface is abstraction barrier. What do I have to do to be on the right side of the enhanced for loop? Well, really what I have to be able to do is provide a stream of values. It's slightly more, there's like one additional level of indirection there, right? Because what I really need to do is to be able to provide something that provides a series of values, right? In our example, we do those both in the same object, but you can separate those out. So there are some objects that will provide a separate iterator, and actually we could look at how to do that once we get to tomorrow. Maybe that's something that I'll add to tomorrow's lesson, which is on anonymous classes. So anyway, but for now, we're having our class implement both of those interfaces, meaning that it's going to have to track. So an iterator has to track some state, right? It has to know like where am I in this list of series of values, and how do I provide the next one? And in this example, what we've done is we've mixed together the state of the class. This is a class that just counts down from a value, and the state of the iterator. That's not always what you want to do, right? Imagine I had a class that saved an array of values, and I want to iterate through those. I need separate state for the iterator and for the class. The class has an array, the iterator has a position in the array. Every iterator might have its own position, so I might be able to do this in a way that creates multiple iterators. And I think actually, like I said, we'll come back and we'll talk about this again after tomorrow's lesson because we'll be able to see how to do this in kind of a cool way. Okay, what I said at the top of the hour when nobody was listening because I was muted, was that we're going to take some questions today because this is another of those walkthroughs that I think is kind of largely sort of self-explanatory. So if you guys want to see some different examples of how to do this, if you want to talk about interfaces, go through some of the recent homework problems, whatever, I'm here, available to you for the next 45 minutes and happy to address any type of questions. I'm assuming people can hear me now because nobody is pointing that out in the chat. So yeah, please go ahead, queue up some questions, and I will be looking forward to answering them. I'm just gonna examples, please. Example of what? Yeah, be more specific. Right? So more things that implement iterator, more things that implement interfaces. I mean, we can do examples of anything. Right? You just gotta give me a little more guidance on exactly what you want to see. And we will do it. We will do it. Examples of what? So yes, I'm happy to do examples. I enjoy doing examples. Just gotta break Java wrappers. Yeah. Break them? I'm not gonna break them. So and that's a good point. So there's this little prelude to this lesson on boxing and unboxing. This is not so the real backstory, as far as I can tell it here, is the following. So Java has a lot of classes and a lot of support for working with objects in really powerful and flexible ways. So for example, think about the code that we wrote last time or the code that you wrote a homework problem recently to find the maximum of an array. We passed it an array of comparables. Comparables in interface. Interfaces have to be implemented by objects. So despite the fact that was really, you know, a really powerful and general purpose way to do it, I have to pass it objects. So how does that work if I want to pass like an array of integers? And unfortunately, as we pointed out here, the answer for arrays of primitive types is not well. That's how it works. So for example, let's go look at the arrays utility class, latest documentation for this. And so you might have wondered why. So let's look at the binary search function. I've got, and I'm just looking at the overloads that don't have a from and a to index. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And then actually 10, but that one we're not going to talk about yet. I've got 9 overloads of binary search. Why? Well, I've got, and it's funny, right? If you think about it, I've got 8 of them that work on primitive types. So I've got these 8 primitive types. Each primitive type has its own binary search method. And then I have another one that handles every other kind of object, right? The Dixon object array. And this is sort of a hint at the fact that in Java, the primitive types don't fit into the object model. They don't, actually. They're not objects. They're primitive types. They live outside of, they're these weird exceptions that live outside of the object model. Now, as we've shown you, you build objects in Java by using the primitive types. So if you take any object in Java and you break it down and you keep going, so let's say your object is made up of like a double and a string. Well, you got a double there, so that's already a primitive type. And then the string, well, what's the string made out of? If I look inside the string, which we've done in the past, I find a character array. So if you follow it down far enough, you always end up with primitive types. That's what everything is built out of in Java. But the objects that you build up with those, in many ways, are kind of what a lot of Java design focuses on. And so the primitive types are sort of special cases, particularly arrays of them. And this is why. So binary search takes an array. This is the same thing for sort, right? A lot of the arrays utility methods take arrays, and therefore they have this problem. That's why you see so many overloads, right? So let's look down at sort, right? So I've got 1, 2, 3, 4, 5, 6, 7. Where's the, I missed one. Wait, hold on. 1, 2, 3, 4, 5, 6, 7, 8. Where's the, oh, Boolean. Yeah, you can't sort Booleans. Okay, fair enough. Right, so I've got this, I have 7 primitive types minus Boolean. Apparently you can't sort an array of Booleans. I don't know why. Does seem like false goes first and true second. I don't know. But, and then you have this object. And remember, the sort requires comparable. So this is anything that implements comparable. So I've got one implementation of sort that can only sort longs, one implementation of sort that can only sort doubles, one implementation of sort that can only sort characters. And of course, it's not going to sort them lexicographically. It's going to sort them according to ASCII order, which is that useful? And then I've got this other sort that can handle any other type of Java object that implements comparable. And so the point I'm trying to make here is that these primitive types in Java are kind of a pain in the butt, right? Like our maximum function, right? So we wrote this really beautiful maximum function that works for everything that's a comparable. Now we've got to rewrite the same code to handle ints, longs, doubles, shorts, bytes, whatever, right? So the boxing types in Java try to address this problem, right? They're designed to kind of try to help primitive types fit into Java's object system. So if I have a function that takes two, let's say I have let's try the, so again, let's think about this. Let's see here. Let's do void, let's say comparable greater than, and we'll say this takes 2 comparables, first comparable second. Well, actually, let's have this return a Boolean, and we'll return first dot compare to second is greater than 0. And again, as always, I'm forgetting this. I think that's actually right. So now let's try this. So this is my greater than function. It takes 2 comparable objects. These are objects. In order to implement an interface, I have to be an object. So let's try calling it on some strings. Greater than 1, 2. That works. Okay. And is this correct? Yes, because 2's later in the alphabet than 1. Okay, what about passing it some... Okay, so it works with integers. Why can I use an integer literal here? The reason is because of boxing. One thing we can do to kind of to show you what's happening that's kind of fun that we haven't done yet is I think there's let's try this. Yeah, check that out. So in Java, and this is something that we don't get into in this class, maybe we'll have a lesson on it this semester because the new format's allowing me to kind of insert some more sort of things that are a little bit sort of that we just wouldn't have touched before, but they're fun. Like they're a one-day type fun, right? One of the cool things about Java, and it's actually really useful and for a certain type of programming that's called sort of meta programming, is that Java objects have this feature called reflection, meaning that Java objects know things about themselves. So for example, Java objects know what class they are. I can ask them by calling .getClass. And in this case, you'll see that the class here is java.lang.integer. Now, I never created a java.lang.integer here. What I created down here is an int. This is an int literal. So when I called greater than, what happened is Java automatically boxed that primitive up in this object wrapper, the appropriate object wrapper for this type, which is java.lang.integer, and then passed it to greater than. And the same thing happened with the second argument. So what's happening behind the scenes is that in order to get this call, this is sort of like casting, although it's not quite the same thing. But in order to get this call to work, Java has automatically wrapped things up in a nice box. You can think of, you can basically think of the object types. We could implement our own version of integer. Now the thing is, the compiler wouldn't help us, right? So for example, let's look at something else I can do here. I can say integer first is equal to new integer 10. Integer second is equal to new integer 20. And then I can say first plus second. And that works. So remember before we said that Java actually doesn't support overloads for mathematical operators. So the arguments to first plus second cannot be objects. There's no way for that to happen. What happened here is that the compiler saw this and it unboxed those boxed types for me. So when I started evaluating that expression, first plus second, I was starting with capital I java.lang.integers. Then Java said, oh no, I'm trying to do math here. I need primitive types. Can I automatically convert this to a primitive type? The answer is yes, I can do that. I can take an integer and I can unbox it. I can pull the int primitive out of it so that this expression will work. So this boxing and unboxing for individual values is something that the Java compiler will do for you. Like I said before, it does not do this for arrays, and that's an irritation in the sense that it'll automatically box individual values to put them into an array. But if you give it an int array, it will not automatically rebox that up into a capital I integer array. And like I said on the lesson, I'm assuming there's some technical reason for this, but I do not know what it is. Let's see here. Is there a way to sort an array of objects by their reference names? So let me do these questions backwards. Pran, I won't get to your question. So comparable is only one way to actually implement this. So when you think about it, what you're doing with comparable is you're really establishing a way for one instance to compare itself to another instance. So it's not really, you can't really do that on a class level. Now you could do that based on, so remember we just saw get class. So if you give me an object in Java, I can figure out what the class is and I could build a sorting method based on that. The problem is that other classes wouldn't support it, right? The other way to approach this, and I'll pull this up right here, right, Java also has an interface called comparator, okay? And comparator is different than comparable. What comparator does, I'll show you, right? in order to implement, this is another interface, but is it an interface? Yeah, okay. To implement comparator, I think really the only thing, I don't know how many of these methods you actually have to implement. The main method is this one. So what comparator does is comparable is like you're asking one instance, how do I compare you with this other instance? When you're thinking about a static method, you probably actually you can't run that on an instance, right? And so comparator is more what you're after. A comparator has this method compare that takes two instances of some object and compares them for order. And then if you look at this, the documentation is actually very similar to comparable. The difference is you're not comparing this object to some other object. You're past both objects to compare. And on some level, that's a lot more flexible, right? Because you can handle different types of objects and you can do things in a different way. It also doesn't require, so one of the requirements for comparable is that it be symmetric, right? And that can create a problem when you're trying to do comparisons between different classes. We looked at this a little bit, I think, in one of the lessons where we were looking at, oh, okay, I can create something that compares strings based on length, and I could support comparing my object with actual strings, but I can't change string.compareTo because I don't own that class. And so I can never make the comparison symmetric, which is important. The classes that use comparable will very much expect it to be symmetric, right? They're not going to care about which order. So if I give you two objects and you say this one's bigger, and then I swap them behind my back and give them two again, you should pick the same one, right? Because of this comparator, this interface is just a different approach, right? So instead of saying compare one instance to another instance, you're saying here's a function, it could be a static function that compares to it. We'll talk about this more later. I mean, comparator comparator actually cannot be a static method, but it sort of acts like a static method in certain ways. It basically takes two arguments, right? Okay. Then Perrin asked a question, implement using interface. Yes. And then, okay, I mean, the real, from a syntactic perspective, right? It's really easy to tell what you're doing. This code, so for example, this piece of code takes an interface type and uses an interface method. So this is an example of a user of the interface. I'm accepting things that implement that interface, and I'm utilizing the methods that interface provides. In this case, to do a comparison. The code that provides the interface, in this case, I'm using objects of Java that already provide comparable. When you provide or implement an interface in Java, you have to use that implements keyword, right? Like that's the signal that you're implementing an interface. If your class says implements, you're providing the interface, and someone else is potentially going to use it. Now, in languages, we talked about the fact that interface is a concept. It's not just a language keyword. There are languages that don't support like a formal definition of interface, but every language has an informal definition of interface. And at some level, the user and the provider of the interface. I mean, sometimes this is a little bit of a fuzzy, sort of a fuzzy distinction, right? It's really this, like I said, it's this contract that both parties are agreeing to. Sometimes when there's more of an exchange, we use a different word for this. We call it a protocol. And we'll talk about protocols later, right? A protocol involves some type of structured communication between two entities that they use to achieve some goal. That can be done across an interface, right? Where we agree on kind of what are the methods and stuff like that. So let's go back and look at this example, right? So you'll see my class, and it's, I think one of the ways that's good to do this is to look at some examples and say, okay, who's using the interface, who's providing the interface? Well, here I'm implementing two interfaces, iterator and iterable. So this class is clearly providing an interface. What's kind of neat about this example, though, is like, where's the user? Right here. It's this built-in for each loop. So somewhere in the Java compiler, the way that they support this loop syntax is by code that will so when I initialize this loop, it's going to call iterator to get an iterator. Then every time through the loop, it's going to call next and has next to figure out if there's more values and then to get the next one. So, and you can put, I think we did this, right? But you can put, we could put methods in here and we'd see that it gets called, right? And now we'll say, let's put a method in here. We'll say next called. And we'll put a method in here. I'm actually kind of interested to see how this works because I'm not sure which one gets called first. Okay, well that kind of makes sense. Okay, so you'll see iterator gets called once, and that's when the loop is initialized. And then before I see the first value, I see has next, because if has next returns false, the loop ends, right? And then I see next. So the way the interface is being used by this enhanced for loop is every time through, it first calls has next. If has next returns true, then it calls next to get the next value. You'll see down here at the very end, I call next, I get 0. It calls has next again, and that's the last call I see because that time has next returns false and things stop. So this is a case where I see the provider of the interface. I don't see the user because the user is actually, I don't see the calls to next and has next and iterator, but I can clearly see they're happening, right? Some code and I don't think this is a library. I think this is because this is a language construct, it's too tightly integrated. So, but there's some code somebody wrote somewhere, right? We could find that code that is calling. It's like, okay, well, you gave me this thing that implements iterable, so I know that it has this iterator method. I'll call that. Okay, I got something that implements iterator. Now I know what to do. I call has next. If that's true, I call next to get the next value, start the loop, right? So anyway, this is, here I'm the provider because I see the implements keyword. The code that is running the loop is the user of the interface. Down here, on the other hand, I don't have a class that actually implements. I'm using the fact that integers and strings and several other classes that I know about in Java already implement comparable. I'm the user. I don't have an implement, I don't have my own class. I just have a function that's utilizing the fact that there are classes in Java that already provide this interface. So yeah, in Java, you can latch on to that specific keyword. But I think the more, maybe another way to think about it, actually this is true, right? Is the user is calling the methods and the provider is implementing the methods. So I'm calling compare to here on these objects. I'm not implementing compare to. There's no implementation of compare to that's shown, right? Up here, I'm not calling iterator next or has next. I'm implementing them. I provided the code that actually makes them work. So when you provide the code for an interface, you are the provider, you're the implementer. When you use that code that somebody else provided, you're the user. I think that's another good way to think about it. Looking at some examples and kind of thinking this through helps. And you can think about sort of, more real world examples of this as well, right? So, someday you may be working at a software development company and you may have a meeting. That meeting may be decide about, how a particular type of feature is going to be implemented that you're responsible for. And somebody may say, okay, well, here's the interface. And they're going to say you have to implement this method and it does this, and implement this method and it does this, and implement this method and it does this. And they're not going to write the code for you, right? They're just going to say, we'll meet in a few weeks and you tell me when it's done, right? So they don't write the code. You're the provider now, right? Now, again, there doesn't have to be an explicit notion of interfaces here. You might not be using Java, you could be using some other programming language, but the idea is that there's somebody else in your organization, in your company, or on your team who's going to call the methods that you are going to write. They are not going to write those methods, and they don't want to have to care about how you write those methods. They may never look at your code. In fact, they will not want to look at your code. They will just want to be like, okay, you told me, we agreed, this is kind of how it's work. And this is where the contract part of an interface comes in. This is where the agreement, right? This abstraction barrier, right? We come up with some documentation, and then if I have to look at your code, then there's a problem. right? Because we haven't agreed clearly enough about exactly how things work. If we do that well, then I can write my code that uses your feature, and you can write your feature that is used by my code, and the two of us don't have to communicate too much about things once we've agreed on what the interface looks like. I'm just gonna go grab some water. I'll be right back. So, great question. It says, can you add integer objects? Do you have methods on the integer class? So, like we saw, you can add integer objects, but what's happening here is that you're not actually adding them. Let's actually look. I think look up the latest version of the Java integer class. You'll see that the integer wraps a value of a primitive type, contains a single field. And it looks like it does not provide math operations here, right? I don't see an add method or anything like that. The reason for this is because Java will do this unboxing. And it'll actually do unboxing and reboxing in the same statement. So I could do something like this. Integer third is equal to first plus second. So now what's happening when I run this? So now we get to kind of dwell on an assignment again. So Java starts executing the right side of this assignment. And it sees two arguments to a plus that normally would not work, right? I mean, if I made my own integer class, this would not work. It's only because this is built in java.lang.capital integer. So what Java first does is it says, okay, I've got a plus sign. I don't have int or the operands that work for this. So can I convert them into operands that work? And it's like, oh, goody, right? I have a boxed type that I know about. This is why these are important. These are built into Java. Like I said, you can't provide these. The Java compiler is playing tricks here. So the first trick it plays is that it takes those java.lang.integers and it unboxes them to get ints. Then it knows how to add them. What it ends up with when it adds them is another int, a primitive type. Now the variable I'm assigning into on the left is a capital I integer. So now I've got a primitive type on the right and a capital I integer on the left. Now I have to do another conversion. So first and second first get unboxed. I take the primitive values out. I combine them together using the plus operator. And then I rebox that nicely in a capital I integer so that I can assign it to third. And this all happens, without you having to worry about it. It's interesting here because there's a contrast here. We looked at big integer before together. So big integers, on the other hand, have to provide these mathematical operations. So let's go look down here. There's different constructors. So look at this add. We've got add. We have, I think, there's also a multiply method. There's a negation. There's taking it to a power, right? And the reason for this is because the idea behind a big int is that it's supposed to represent numbers that are so large that they can't be stored in a primitive type. So there's no way to unbox it. In a certain way. I can't unbox it to a integer or even to a long because it's too big, right? So the primitive types in Java aren't big enough to hold this. And so the class itself has to provide these special methods. But again, big integer is not something that I think Java will do automatic conversions on. So let's try this, right? Is big integer built in? I think it's a java.util. Okay, sorry. Big integer is where java.math. Okay. So again, see, here's the problem, right? So because it's not one of these boxing types, Java won't do the boxing automatically. There is a way, I think. Let's see here. Well, can I initialize a big integer with an int argument? No. I think I have, is there like a from long? Oh, this doesn't make any sense to me. I don't understand why. It's like I can take a string, it'll take, I don't know why you can't create an integer with, I don't know why you can't pass, I mean, I can pass, so for some reason, I can probably do this, right? I can convert it to a string, and then, oh no, it doesn't like that either, okay. I don't understand why you can't do this. It seems strange to me that you can't take an integer and a big integer from a long. It has private access. That's unhelpful. Let's see here. I was thinking about this the other day. Let's see how to do this. Nope. Big integer Java initialize from long. Oh, this is so dumb. Oh, wait, hold on. Value of? Let's try this. Big integer. Value of. There we go. Okay, so there is a way to do it. This is sometimes known as a. Yeah, I missed this. Geoff should read the documentation more carefully. This is sometimes known as, let's see, where is the constructor summary? That's not what I want. See, this is a static method. There we go, yeah. This is sometimes known as a factory method. So constructors in Java sometimes get used to create new objects when I see new, right? That's a way to call the constructor directly. But there are some classes that provide these things called factory methods. You'll see that it returns, the method returns a big integer, right? So it's static, but the return type is big integer. And so I'm not using new because I'm calling this is a static method provided by the big integer class, right? It returns a new big integer. That's why I'm saving it over here on the left. But it calls the constructor internally. Maybe it does some checks or something like that to make sure that, I don't know. I don't know why I can't just call this constructor directly. But anyway, so there you go. So we cannot add things directly. Okay, I think I've done most of the questions for today. Any other questions? Don't get too fuzzed up about the boxing types. It's just, it's one of these, it's a hack. Let's put it that way. It's one of these things where at some point, Java sat down, people behind Java sat down and were like, uh-oh, we have this problem. So actually, since we're here, Java boxing array, why won't it do this? There is no auto boxing for arrays. I don't know. There is this. Okay, here we go. This article. There's an article about this. I don't understand that. Yeah, I have to read this more carefully. Let's see here. This bug. Oh, I guess they closed it. Yeah, so there are ways to take an array and convert it into let's see here. Looks like there are library methods you can find in various places that will do this for you. I mean, again, we can always if we wanted to, we could very easily write our own methods to do this sort of thing, right? So let's go back here. We could always say, let's see here. We'll call it. We'll have it return an array of integers, box array. We'll have it take an array of integers. I'm not going to do it. Well, I'll do a null check here, and I'll say for int, and then I'll say integer box is equal to new int integer values dot length, and then I could do for I is equal 0. Well, how about this? I'll just do for int value in values boxed I is equal to value, and then I'll return boxed, and this would work. So we'll do something out of println box array new int 1 2 5. Why is it upset with me here? Oh, the variable I, right? I can't do this way. I have to use the old-fashioned for loop. Nope. There you go. So that's now an integer. You can see this is hard to. How about we do this? Arrays dot. We use the Java arrays class. Arrays dot toString box array. There it is. Yeah. So this works fine. So we can write this like silly little utility method to do this for us, but Java won't do this automatically. Too bad. So in this example, the trick here, so I'm creating my own array of capital I integers, and then the trick is Java will box individual values, right? So that's what's happening in this assignment. Yeah, it's a great question. I could do this. This would work exactly the same way, but I don't have to. Oh, hello. Instead, what I can do is if I do this, Java's basically going to add that new integer for me, right? So it's going to say, oh, okay, wait, hold on. On the right side, I have an int, primitive type. Left side, something that needs an integer reference. I know how to do that, right? I'll box that for you. So again, it'll box individual values and unbox them when needed. It just doesn't box arrays. And so what we've done here is we've built an array boxer that exploits the individual value boxer. So we can't box the entire array automatically, but we can box individual values, and so we can apply that to box the whole array. Again, I don't know exactly why they won't do this. One of the things, and this somebody asked us on the forum, this was a great question. They said, well, why does Java have these built-in, why don't we just use the built-in objects that represent numbers? And there are languages that do this, right? So for example, in Python, anything that you create that's a number is actually kind of an object, right? And that's why you can create these massive numbers in Python with no problem. So Java's sort of an interesting language in certain ways. So on some level, it's an old language, right? And on some level, it still has, and it has built-in memory management which certain languages at the time didn't. So that was a big step forward. But Java still has these interesting touches with lower level programming. So for example, in Java, you can still design objects that use these primitive types. Now these primitive types have problems with them. They have limitations, and a lot of those limitations are associated with the fact that you're very, very directly tied to individual features of the machine. So for example, an integer is 4 bytes. 4 bytes of memory, 32 bits. Each one is 1 or 0, so that's 2 to the 32 values, and because I center it around 0, I get, from 2 to the 31 minus 1 to negative 2 to the 31, right? 2 to the 32 possible values. You have to add 0, that's why I get the minus 1. So on some level, Java has these interesting features that are like kind of left over from older languages where you actually really care about this. If you go on and you program in C or C++, there's no these concepts become much more natural, right? You get much more used to just picking for example, again in Python, on some level, like Python tries to pretend that every number that you use when you use Python is an infinite precision floating point number. That's not always true, and there are some inaccuracy problems that you can run into, but it sort of tries to allow you to pretend that. JavaScript does the same thing. It's like a number's a number, right? I mean, we got big numbers, we got big numbers. We got small numbers, we got numbers with lots of decimal points and a few decimal points. It doesn't matter, right? The primitive types in Java are this throwback to a time where, and we still live in this time, but they reflect something about the underlying machine that not every high-level language does. So that's kind of where they came from. They're also, the trade-off here is also that they're, from a memory perspective, they're much smaller. So a Java object, even the Java objects, actually we can look this up. Let's see, Java boxing memory overhead. Let's see here. So, okay. I mean, essentially, the trick here is that an integer primitive, an int, is 4 bytes. A capital I integer is bigger than that, and potentially quite a bit bigger. And so creating objects in Java is a more expensive operation from a memory perspective than creating primitive instances of primitive types. And so, let's see here. Let me back up a little bit. We'll go back to before I did this all. Where was I? Yeah. So this operation right here. So I've got things that are objects. So I've already auto-boxed them. So I already get these big objects rather than just the 4 bytes that I would need to store an int. And now I've got to unbox them, which requires some time. And then I'm going to combine them and then rebox them, and I put them in this big container. And all this, think about it, all this boxing and unboxing. It's like rewrapping presents, right? It takes time, and it takes up space. So it's not necessarily a bad way to think about it. It's like the int value is this little thing, and then to make it an object, I've got to put a wrapper around it, and the wrapper is now like this big thing, right? And there's a little value in there, right? But there's also this other stuff, right? That is involved with being a Java object. It's just some memory overhead that's inescapable. And so, for example, if you I would not worry about this too much when you're just getting started building stuff, right? But on some level, if you had a lot of data and you needed to store it in a way that was memory efficient, you would probably consider putting it into a primitive type array and dealing with the limitations rather than putting it into a boxed type array or worse yet, using something like big integer, which is going to introduce a lot of overhead compared with just a small array. So anyway, great question. Doesn't the for each array call the iterate method though? So how does it work? Because it does. So it's a good question. This for each loop takes either, so if you look at the definition of it, it takes one of two things. Either something that implements iterable or an array. So arrays here are a special case, right, that are handled differently. And so if you looked at how this was implemented, there's some if statement there that says, if this is something that implements iterable, do this. Otherwise, if it's an array, do this. Otherwise, shriek at the top of your lungs, right? So if I try to put like a string over here, right, it essentially says you've got to implement iterable. The string doesn't implement iterable. I can put any array over here that I want, right? I can put a new string array, 1, 2. Oh, it doesn't like this, and it's probably because, there you go. Just the syntax here. So arrays work, right? Arrays do not implement iterable, but the for each loop handles them differently. So that's the trick here. So essentially, the for each loop, and this is one of those places where it's sort of designed around backwards compatibility, right? I think Java had arrays before it had the iterable interface or this enhanced for loop. And so when the enhanced for loop came around, the designers were probably like, oh crap, we got to make it work with arrays too, and they don't implement this, so we'll have some special case in the code that allows us to do the right thing with arrays. It's not hard. I mean, you could implement this code yourself on an array. It just involves using an index and walking through the values, right? But those are handled differently. Yeah, so it's a good question. All right, I think that's enough for one day. So tomorrow and Friday, we're gonna, this is kind of the end of our work together on Java objects and object syntax. Starting next week, we're going to move into the third half of the course, which is really my favorite part because you guys know enough now to be dangerous, and we're going to put that to work, and we're going to start talking about some algorithms. We're going to build some cool things together. It's going to be neat. But we have a couple of additional things, and the next 2 lessons we're going to get weird, right? We're going to do some gnarly stuff. This is syntax and ideas that I suspect will be new to many people, even those with some Java background. So, but there are things that we're introducing with a very, very strong sense of purpose, right? Because these are those things you guys will be using quite soon. So tomorrow we'll talk about this idea of being able to create an anonymous class in Java, which is a an object that implements a class that was never declared anywhere, which is pretty wild. And then on Friday, we'll take that idea one step further, and we'll actually look at being able to basically being able to have a value in Java that you pass that's just a method. So we can actually pass, now in modern Java, we can actually pass a method to a function. And you know, how we get there in Java is a little bit of a journey, but we'll do it. And that actually turns out to be a pretty powerful idea. So anyway, I'm looking forward to that. I will see you all tomorrow.